In this video, I will be illustrating how to do electrolytic cell calculations. Okay, but before that, I just run through a very quick overview. For electrochem, there are two aspects, two parts: galvanic cells and electrolytic cells. Galvanic cells, E0 cell is positive, and they use a spontaneous chemical reaction to convert chemical energy to electrical energy. Other names for galvanic cells would be electrochemical cell or voltaic cell. Electrolytic cells, on the other hand, are different because they have an external battery. That's electrolytic cell. Okay? Electrolytic cell requires electricity in order to occur, and you can compare and contrast the differences. So for electrochemical or galvanic cell, spontaneous reaction, E0 cell is more than 0 and so on. This one is more spontaneous. And give you an example, electrolysis of molten sodium chloride. Okay, because in the electrolysis of molten sodium chloride, the only species available are Na plus and Cl minus and nothing else. So Na plus will go to the cathode and get reduced there to Na. Cl minus go to the anode and get reduced there. Cl minus go to the anode and get oxidized there. Is that okay? Yeah, so for electrolysis of molten sodium chloride, you don't see that happening. Your table salt at home doesn't become the element sodium and chlorine gas. You need the external electricity to force it to occur. And as you know the difference between the setup, okay, so recognize the battery is electrolytic cell, and please also know the signs. Okay, for electrolysis, it's very easy to remember because anode attracts anions, so anions are negative, right? Therefore, anode must be positive to do that. Cathode attracts cation. Cation are positive, right? So your cathode has to be negative to attract the positive cations. That's for electrolytic. Okay, easy to remember. Okay, so you need to know all this. Okay, so you can see that these are the signs of the electrolytic battery. Electrolytic cell has always got a battery. Okay, and this is the setup. Okay, I just want to remind you of Euleric oxidation is always loss of electrons. Reduction is always gain of electrons. Now we are going to move on to the electrolytic chem calculations. Let me run through the general steps to solving electrolysis calculations, equations. Write down the balance equation, the half equation, and the electrode. For example, chromium 3 plus could be reduced to chromium solid. Write down the mole ratio between the number of moles of electrons to the number of moles of species you are interested in. If you are interested in the number of moles of the chromium deposited, then number of moles of electrons over number of moles of chromium is n is to 1. Use Q charge is current times time. Charge is number of moles of electrons times Faraday's constant to solve for n. After you solve for n, sub in. After you find the number of moles of electrons, you sub in this value here, and then you'll be able to find the number of moles of chromium if you know the mole ratio. And sometimes it's the other way around. Okay? I'm just going to use the PJC prelim question to run through this again with you. Okay, a recap of how to solve electrolytic calculations. So sodium ethanoate can be used to prepare ethane by electrochemical reaction like this. Okay, it's formed at the anode, and we know that at the anode what happens? It is an oxidation. Okay, the anion is oxidized. Anion goes to the anode, is oxidized. So it's oxidized to this ethane and so on. And this student investigated electrolysis of aqueous solution of sodium ethanoate using this graphite electrodes in the litmus solution. So if you want to know what are the species that's oxidized at the anode and reduced at the cathode, first identify all species. So what are all the species present? It is CH3COO minus, okay, Na plus, and water. And then you realize that at the cathode, what can be reduced? It is possibly water can be reduced. Okay. or at the cathode cation, Na+. But you realize that we actually don't really have to consider Na+, okay, because potentially at the cathode I can have water and Na+ being reduced. Okay, basically for aqueous electrolyte, I always have to consider water can be reduced at the cathode, water can be oxidized at the anode. Then you compare the E0 to see who is more easily reduced at the cathode, for example. But in the case of water, the E0 reduction is much more positive than the reduction of Na+. Okay, so water will be preferentially reduced at the cathode. So this is what happens. For the equation that occurs at the cathode, please write the full forward arrow because it really occurred already. Really occurred. So therefore like that. Full forward arrow. And you go to that booklet and check water is reduced to give H2 and OH minus. Okay? And at the anode, okay? At the anode, what are the species that can be oxidized? It should be just water as well as the anion. And because I didn't give you the E0 oxidation, okay, but I told you that this reaction occurs, so we have to assume that this one, the E0 oxidation, is more positive. Therefore, CH3CO minus is oxidized. This is the assumption we make in this question because they already told you this. They already told you that ethane is produced. Okay, by the oxidation of ethanoate. Okay, if I want to produce this amount of ethane, what is the current that I need? I'm interested to find current I. Okay, so what I do is I find the number of moles of ethane first. And then from this equation, very important, okay, so you go back and look at what we need to do. Write down the balance equation at the electrode. Okay, so let's do that first. Okay, so you calculate. Okay, so let's look at the calculations very quickly. Okay, first step, how to do electrolytic calculations. Write balance equation at the electrode. We get this. Write the mole ratio between number of moles of electrons and number of moles of species liberated. We get this. Okay, number of moles of ethane is to number of moles of electron is 1:2. Okay, then you calculate number of moles of ethane by dividing 1.5 by the MR. Then after calculating number of moles of ethane, I times 2 to get number of moles of electrons. Finally, what do we want? In step 3, we'll use Q is equal to current times time and Q is NEF to calculate what we want. We want to find the time taken. So we are interested in this time. And if I were to sub in this number of moles of electrons 0.1, Faraday is 96500, the current is 5, and I can find the time in seconds. I convert to minutes. Okay, so is that okay? So what do you want to find? You want to find the time. So if you want to find the time, you sub in into these equations, and then we can find the time. Okay, number of moles of electrons, 0.1 times 96500 divided by the current. Okay, then that's the minutes, time in minutes, divided by 60, we get time in minutes. Sorry, the time is actually in seconds. So if I don't divide by 60, okay, if I don't divide by 60, then I'll get the time in seconds. But I divide by 60 to get the time in minutes. That's all, okay?